Okay, guys, before you take your quiz, or if it's after you take your quiz, you might be seeing some mistakes. I tried to video this in class and get feedback, but then an alarm went off and it shut the video off and I lost it. But anyway, so I wanted to compare for you two problems that seem very similar, and every year people try to take these shortcuts, or they don't learn process and they learn patterns, and they start getting lured in by patterns, and it costs them severely on this test. And I don't want that to happen to you. So I'm doing a little something extra this year, and I want you to see side by side maybe where your shortcuts are going to cost you if you try to take them. And by the way, I'm a shortcut kind of guy. If there were good shortcuts, I would be giving them to you. I'm not suggesting that you might not be able to come up with some, but if you think you have, you might want to run them by me and let me troubleshoot them for you, okay? So I'm doing two problems side by side. One with cosine of theta equals negative 0.4163, and one with cosine of 3 theta equals negative 0.4163. So exact same problem, except one has a theta and one has a 3 theta. And you have the same intervals, 0 to 360. Now in the past, people that do poorly on this part, and this part will cost you maybe 2 letter grades if you don't have this part down. All right? People who do poorly start doing this. The first thing they do, they make a mistake, is they just inverse cosine and they don't make that a plus. And if you don't make that a plus, your calculator spits out 114.601. The problem with that is you don't know the reference angle. And even though you're going to know the first angle, you're going to have to go back and find the reference angle to find the second angle. Well, sometimes your calculator spits out the first angle like this would have. It would have spit out that if I don't change the sign. And it's not the reference angle, but sometimes it is the reference angle. Well, that leaves you two different kinds of problems. Unless, like my suggestion, change that negative to a plus when you do inverse cosine, and then every single time it'll spit out the reference angle. That to me is a better plan. That way you can do every single problem the same. I take that reference angle that my calculator gives me, because it gave me that when I put a plus, and I'm going to locate that reference angle wherever cosine had negative values. And remember, this ugly little decimal is really just it's like a unit circle value, but it's one that I don't know. Okay, so that right there is like an adjacent over hypotenuse, just simplified. We just don't recognize it. So my calculator allows me to find that angle. Since my unit circle, I didn't have that memorized, right? So I locate that reference angle where cosine would be negative, which is in the second and third. So if the reference angle's there, then the actual angles, which are the green angles, would be 180 minus the reference angle here, or 180 plus the reference angle here. And a lot of you guys see this 0 to 360, and you are in the habit of thinking this. I know, because I see it every year. Or you're just not learning the process. But a lot of people are in the habit of thinking, oh, if it's 0 to 360, I don't need my formulas. And in this case, you didn't. And if you wrote those two down, you would have been correct. Except I'm not going to give you 0 to 360. I might give you negative 200 to positive 200, which means this one doesn't show up, but maybe if I subtract 360, the other one does. I might give you negative 500 to positive 500, and see how many of these actually locate in this region. So you need these formulas habitually to write them down on these problems, and then use the formulas to figure out the angles in the interval. Now, a lot of you are like, nah, I got this under control. I hear that every year. Okay, let me show you where you're going to get into trouble if you don't get in the habit of doing these problems. Now, even when it's 0 to 360. So check it out. Over here, same problem, but a 3 theta. Now, first of all, you cannot divide by a 3 on both sides. Lord, have mercy. This is not 3 cosine theta, where it's a times 3 and you can divide by 3. Now, if you get rid of the cosine, which is what I'm doing by inverse cosining it, then the 3 is exposed. We can later divide by that 3, but don't do it yet. Okay? I am going to ignore this. All right? I'm going to pretend like that's just a big beta, all the way down my problem until the very end. So the work for a problem with a 3 theta or a theta over 2 or anything else should look exactly like your work over here for a regular cosine of a single angle. It should look the same. Don't go pulling out a triple cosine formula, a triple angle cosine, or a double angle, or a half angle. Don't do that. It makes your life miserable, okay? It's creative, but you're not going to get very far with it, okay? So right here, I get it down to reference angle, reference angle. Notice this part looks exactly the same. And notice I'm keeping that decimal too. For those of you who are thinking, why don't you just round it? It doesn't affect your work. Well, over here it wouldn't. And I probably could round it right there. It would be 0.4, 0.6, 0.4, and it would have been fine. But over here, it's not necessarily the case. Because when I divide later by this 3, those other decimals come into play, and they often change that decimal for what it would have been if you just rounded from the beginning. And you're going to see that. And I'm going to pick problems that will expose that. So if your decimals are off, it's going to cost you, okay? And if my decimals are off on my keys, tell me about them and I'll give you a bonus point. I think Haley already found one of them. Okay? So right here, I'm going to keep that decimal, and it's the same problem, but I'm not dividing by 3 here. I'm saying, where would the triple angle reference angle be? Same quadrants, therefore same 2 angles, 114 and 245 as I had before. Now, if I'm not in the habit of writing these formulas out, here's what happens. People just go, oh, the 3 theta is 114. They divide by 3 and they get 38.2, and they write it down. And then they divide the 245 by 3 and they get 81.8, and they write it down, and then they're done. Why? Because they make their angles later. They go and they get this 38.2, and then they write plus 360n. And adding 360 to that puts me outside of that interval. And they got bad habits. They formed bad habits over here by getting used to saying, oh, you don't need the 360 formulas. You don't need them. And then they say, oh, well, you don't need them here also. And then you end up missing 4 of the 6 answers. And more critically, you didn't learn what I was trying to show you. And on a problem like this, I'm not going to give you credit for doing this like you did this. It's a different problem. It's like I don't give you credit for adding 2 plus 2 is 4, because we already know how to do that. This is old mentality. This is a little bit new mentality, although I think we did it last year as well. Although it was during the spring when you guys were corona'd up. Okay, so right here, what you're going to do is the exact same thing you did here, hopefully, with the formulas. And if you have the entire formula written out, then to divide that 3 away, it affects the 360. And because it affects the 360, now I'm adding a different number to these angles, which very well may give you other angles that are in that interval. And if you try to take shortcuts on this process, it will cost you. And if you try to round here too early, it very well may cost you. So if these decimals are off because you rounded that too early, you're going to get dotted. If you forget to do the equations you divide by 3 before you do the equations, you're going to miss these values. And it's going to cost you at least a slash dot, 75% of your credit on a problem like this, at least. Because, again, finding a reference angle, that's not what I'm really trying to test here. That's what I'm trying to test here. All right? Are y'all with me? Okay, take that big quiz. If it's got the solutions there, go through them. If you're missing something or still don't understand something, you guys will be here tomorrow. Make sure you ask me right at the beginning of class quickly. But if not, good luck on that, and I hope we're in good shape. Tomorrow we're going to start graphing sine and cosine, maybe get into tangent. And for those of you who remember last year, that was when you were at home with open notes. My guess is you probably didn't learn it as well. So make sure you're watching the videos on graphing the trig functions that will all begin tomorrow. All right? See you.